In this podcast, I want to solve these two inequalities. And remember, we treat inequalities just like their equations. You just have to be very careful when you're dividing or multiplying by a negative number. And we're going to see that in this particular podcast. So we're going to solve 3x plus 1 is greater than 10. So in order to solve this, I'm going to use my properties of equality. And really, it's the same thing if there's a greater than or less than or greater than or equal to, less than or equal to. If you subtract a 1 from both sides, if you add or subtract something from both sides, that is fine. It does not change your inequality. It does not change your equation either. So here we're going to subtract a 1 from both sides, and now I can divide by 3. And I get x is greater than 3. Now let's just think about that. This is saying that all numbers greater than 3 are going to satisfy this inequality. Well, let's just choose a number that's greater than 3 and see if it works. So I'm going to choose 4. So we see that 4 satisfies this part, this ending part, a number greater than 3. So let's plug that in. 3 times 4 plus 1 greater than 10. We get 12 plus 1 is greater than 10. We get 13 is greater than 10. So good, that works. So that's just a check. You'll see why I did that. But you see here we're going to mark a 0. We're going to mark 3. It's going to have an open circle because we don't want to include that number 3. And the reason why is this is a strictly greater than. It's not greater than or equal to. So we're going to put open or closed circles. We're going to mark the numbers that satisfy this inequality. 3 does not satisfy the inequality, so it's going to have an open circle. And now we want all the numbers larger than 3. Well, that's all the way over here. So if you bear with me here, I'm going to now come over to this side, and I'm going to solve negative 5x greater than or equal to 20. So let's just see what happens when you divide both sides by negative 5, what we get. We get x greater than or equal to negative 4. So that says if I choose a number that's greater than or equal to negative 4, it should work when I plug it back into my inequality. So let's choose 0. 0 is greater than or equal to negative 4. So if I plug in a 0, this should make this inequality true. So I get 5 times 0 greater than or equal to 20. I get 0 is greater than or equal to 20. Okay, something's wrong here. I solved that inequality, and I see here that, well, I should be able to choose any number greater than negative 4 and have it work in the inequality, but it didn't. I chose a number greater than negative 4, and it did not satisfy the inequality. The reason why is because of this step right here. We are dividing by a negative number. When you divide by a negative number, or when you multiply by a negative number with inequalities, you have to remember to switch your inequality sign. Because what you're doing when you're multiplying or dividing by a negative number is really multiplying by its opposite, finding the opposite of what's really true. So when you divide this both sides by a negative 5, remember to switch the inequality. And now if we choose a number, let's say negative 10. Well, negative 10 satisfies that inequality. Negative 10 times negative 5 gives us 50. 50 is greater than or equal to 20. So you can see here that we just need to, when you multiply or divide by a negative number, just remember to switch the inequality sign. So I'll mark my 0. I'll mark my negative 4. It will have a closed circle. A filled-in circle because we have less than or equal to, right? Since it's or equal to, that number negative 4 will satisfy this inequality, so that's why we need to include it on our number line. And now all the numbers that are less than negative 4, well, that's all the way down here.